All right, so you should have your notes packet out, and on the front of your notes, you want to copy down our lesson goal for today. So we are doing lesson 2.2, probability with combinations and fundamental counting principle. And so when we are done today, we want to be able to find the probability of an event with combinations and the fundamental counting principle. Okay, so we want to have the ability to do a probability problem with both of those. Now, as we're going through today, make sure that you hit pause if I'm going too fast. If you need to rewind something, go ahead and do that. So our first problem is about as real life as you can get for probability. So I'm assuming you have heard of the Powerball before. It's the lottery, like, you know, when you go to a gas station or whatever, they always have the signs up with how much is in the Powerball and the Mega Millions and whatever other one there is. And so we're going to talk about the Powerball. That's the biggest one that we have in Minnesota. And so how it works, beginning in October 2015, Powerball became an even larger combined large jackpot game and cash game. Every Wednesday and Saturday night at 10:59 p.m. Eastern Time, so 9:59 Central, we draw 5 white balls out of a drum and with 69 balls in it, and 1 red ball out of a drum with 26 red balls. This change means bigger jackpots. It also means your odds of winning some prize are improved. And so we want to know what's the probability of winning the Powerball. And so one, you have to know how the Powerball works. And so if maybe you've been with mom and dad when they have gone into a gas station and bought a Powerball ticket. And so basically you go in, if you want, you can pick your own numbers, but most people just say, give me a Powerball ticket, and then the computer just kind of randomly picks them, okay? And so you get this little slip of paper, it's printed out, it's got 5 numbers on it, and then there's 1 red ball, Powerball number, okay? And so how it works is they have this big spinny drum that they call it that's got 69 balls in it. Those are the white ones. And basically they pull out 5 of them. And then after they do that, they have a different drum where they pull out 1 red ball that has 26 of them in it, okay? And then it was 5 white that we're going to pull out. And so the probability of the jackpot. So you got to figure out how is it or what is it that I want. So I want the 5 white balls and the 1 red ball. So think about order. The white balls can come in any order. At the end, they put them in numerical order, but as they're coming out, it doesn't matter what order they come in. And so that's what makes this a combination problem. And so we have 69 of them available, and we want to match 5 of them. So there's 5 we want to choose. So we need to have 5 white balls and 1 red ball. So remember, and means to multiply. And so there are 26, choose 5, whoops, sorry, choose 1 red balls available. And so go ahead and hit pause, and then I want you to type that into your calculator. Okay, so once you type it in, I believe you're going to get 292,201,338. So that's all the different combinations of numbers 1 through 69 and then 1 through 26 that we can pull out of these drums. Well, out of all of those numbers, we got to figure out how many combinations are the winning one. And there's only 1. So we have a 1 out of 292,201,338 chance of winning the Powerball. Okay. Now it says, did we do it right? So if you go on to school, or not go on to Schoology, if you go onto their website, the Powerball website, they have all the odds of all the different ways that you can win. And so the way you win, if you match 5 whites and a red, you win the grand prize, and the odds of winning are 1 in 292,201,338. Exact same number we just got. Okay? All right, go ahead and flip the page. We want to go to the next one. Guessing on the test. So our last test had 9 questions with 5 answer choices and 15 questions with 4 answer choices. What is the probability that you would ace the test if you randomly filled in the answer sheet? Okay, so if we're just going to totally guess on it, how would it work? Okay, and so I'm going to kind of show you up here. I'm going to do the 9 question part, and I'm going to kind of do it away from this problem. So if we have 9 questions, that means think about what we did last chapter. I would have 9 different blanks. And each of those blanks would have 5 choices for A, B, C, D, E, basically. Okay, and then I could do the same with 15 questions, and it would have 4 blanks. But I don't want to write out this huge math problem. So kind of think of your algebra skills. If I have all these 5s multiplied together, another way to write that would be 5 to the 9th power. And then if I did the 15 questions, each of those blanks would have a 4. So there's 15 4s being multiplied together. Okay, go ahead and type that in on your calculator so you can see what kind of answer pops up. Now I'm hoping you're noticing, and make sure you hit pause if you haven't finished this yet. I'm hoping that you're noticing it's a really big number. It should be popping into scientific notation. And so I just picked a few of the first numbers. I didn't go all the way down. So 2.097 times 10 to the 15th. And so then part B, how many correct answer keys are there? So think if we have a test, how many ways are there to get the perfect score? 1. There's 1 correct answer key. So now when we talk about what's the probability of getting them all correct, there's 1 correct answer key out of 2.097 times 10 to the 15th ways to get the test right. So kind of think about it this way. The test we just took, you have a better chance of winning the Powerball than randomly guessing all of the correct answers. Okay? Good thing you guys all do your math homework. All right, next page. So probability. All right, so remember every probability problem comes down to the same fraction. The number of successes over the total number of outcomes. Every single one, no matter how hard the probability problem is, it always comes down to this. Number of successes out of total number of outcomes. Okay, so first one, you are dealt a 5-card hand from a standard 52-card deck. What is the probability of getting 5 face cards? Okay, so we want 5 face cards in our hand. Okay, so I'm going to do that on the top. That's our success. We want to get a face card. So the first thing I got to figure out is, what kind of problem is this? So remember when we do the cards, it doesn't matter which card I get first, second, third, fourth, or fifth. So that means this is a combination problem. Okay, and so next thing I got to figure out is, how many face cards are available? And so if you think of the 4 suits, there's Jack, Queen, King in each suit. That means there are 12 face cards available, and we want 5 of them. Okay, so 12 face cards available, we want 5 of them. Now the bottom is going to be all the different 5-card hands I can make, no matter what cards pop up. And so there are 52 cards available, and we are choosing 5 of them, and we've seen that math problem before. So now I would do each part of the fraction separately. So on the top, go type in 12, choose 5, and then write your answer down. And then go ahead and then do 52, choose 5 on the bottom and write that answer down. Make sure that you hit pause and type those in. Don't just wait for me to write down the answer. All right, so if I do 12, choose 5, I'm going to get 792. If I do 52, choose 5, I'm going to get 2,598,960. Okay, So the next thing we need to do is we need to take these two numbers and we need to divide them. So go ahead and take 792 divided by 2,598,960. And I'm going to go out to 5 decimal places. Okay, so make sure you go ahead and write down out to 5 decimal places what the answer would be. And so when I do that, I got 0.00030. Okay, so if you think like percent-wise, 0.03%. Okay, that's like 3 out of 10,000 people. Okay. Part B, what is the probability of getting exactly 3 aces? Now this one's a little bit tougher. So probability of 3 aces, and we want exactly 3 aces, but our hand still has 5 cards in it. Okay, so first thing I'm going to do is aces. There are 4 aces available in a deck of cards. We want 3 of them. Okay. Now, what makes this one difficult is you need to remember we need 5 total cards in our hand, and we want 3 of them to be aces. So those last 2 cards can't be aces. They can be anything else we want, but they can't be aces. So there are 48 other cards out there that are not aces, and we want 2 of them. And then on the bottom, it's just going to be that same problem. 52, choose 5. So I know the bottom of this is going to be that 2,598,960. Okay, go ahead and hit pause, and then you want to figure out what's the top number going to be. Okay, so make sure you can type that in. Make sure you know how to multiply things together. All right, so I got 4,512, and then I'm going to divide it. And so I'm going to get 0.01736. That's my probability basically. And if you want to know what that is as a decimal, or I'm sorry, as a percent, it would be a 1.736% chance of getting exactly 3 aces. Okay. All right, we're going to skip this one down here, and we want to go ahead and go find this problem. So go ahead and flip your notes. All right, example 2, it says you have 35 students in your class. 20 of them are girls. Your teacher is forming groups of 5 for a project. Part A, how many different groups of 5 can be formed? Okay, so we have 35 people in our class. We want to choose 5 of them for a project, okay, or for a group. Okay, so this will tell us how many different groups can we make. So when I type that in, I get 324,632. Okay, that's how many groups we could make out of a 35 student class, and then the groups would have 5 people. Okay, so now we're going to get into kind of similar to what the committees we did last chapter. We're going to get into like how many boys, how many girls, all of that. Okay, all right, so I'm going to write the math. Let's get the math problems written down, and then we can pause and kind of do all the calculator work. Okay. All right. So we want probability that a group contains 5 boys. Well, if there are 20 girls, that means there's 15 boys available. And so I've got 15 available. I want all of them to be boys. Okay. And then the bottom would be that 35 choose 5 problem, okay? And then we're going to come back and do the math on this in a little bit. I'm just going to get the setup going, okay? Next one, now we want 4 boys. Well, there are still 15 boys available. We're going to choose 4 of them. But now my group's not full. So that means we have to have a girl in our group. So I'm going to have 4 boys, and that's why I'm putting multiply here. And then we have 20 available, we're going to choose 1. So this is 4 boys and 1 girl. Okay. Now the bottom, still going to be that 35, choose 5. And then we will, like I said, we'll come back and do the math on all of these in a second. Okay, if I'm going too fast, you need to make sure you're hitting pause. All right, so next one continues to be the same idea. We have 15 boys available. This time we want 3, but my group's not full, so I got to fill it up with girls. So 20 choose 2, and then 35 choose 5 again. Okay, so I want you to hit pause right now, and I want you to try to do the math problem for these 3. Get this initial fraction set up for each of these. So go ahead and hit pause and then do that. Okay. All right, so 2 boys. You should have 15 choose 2 times 20 choose 3 this time, and then 35 people choose 5. Down here we have 15 boys, we're choosing 1, which means we have to choose 4 of the girls. And the last one, we're going to choose 0 boys. So I'm not even going to write that part of the fraction. That just means we have to have all girls in our fraction, okay? All right, so now we want to basically, once you hit pause, and what I want you to do is go find what's going to be the actual number on the top and the bottom. Now the bottom, we already figured out. The bottom of every one of these fractions is going to be 324,632. What's going to be different is what pops up on the top. So go ahead and hit pause, and then in about 5-10 seconds, all of the answers are going to be up here, but it's better if you go type them in and get them. Okay, so these are all the fraction answers, and now what we really want and what we're going to enter on Schoology are the percent answers. And so next thing we need to do is take our calculator and take the top divided by the bottom, and then we want to round it to what's called the 1/10 of a percent. And so you want to make sure you're typing these in and seeing what your calculator looks like so that your answers match mine and you know how I'm getting my answers, okay? So this one here, I believe when you go and divide it and then slide it over a couple spots, you're going to get 0.9%. Over on C over here, when you go and divide it, I believe, and then you slide over a couple spots, I believe we're going to get 8.4%. So remember, I'm rounding after I slide it over a couple spots to 1/10 of a percent. So when I'm looking at my calculator, I need to see at least 4 of the decimal places because that 4th one tells me how to round. This one, I believe we're going to get 26.6%. This one, we're going to get 36.9%. Down here, we're going to get 22.4%. And the last one, we're going to get 4.8%. Now, it was kind of a pain to get all these answers on here, but we wanted them on here because of what's coming up down below. So now that we have all these answers, this piece down here should be easy. It says, what is the probability of the group contains at least 4 boys? So remember, that means 4 or 5. Well, the math problem was already done. Here's 5 boys. Here's 4 boys. So 8.4 plus 0.9 is going to give me 9.3%. So the probability that we get a group that has at least 4 boys in it is 9.3%. Okay. What is the probability the group contains at most 2 boys? Okay, so at most means I could have 0 boys, or I could have 1 boy, or I could have 2 boys. Okay, and so 0 is 4.8%. 1 is going to be 22.4%. And 2 is 36.9%. And now remember, I'm just getting those numbers from the piece we just did up here. So here's the 36.9, here's the 22.4, here's the 4.8. And so if we add those together, we have a 64.1% chance of getting at most most 2 boys. Okay. All right. I want you to flip the page, and then there are 2 problems here for you to try. So I want you to go ahead and read it, set the problems up, and solve them before you watch the rest of the video. Okay. It's important that you're doing things on your own. All right. So first one says a committee of 6 people is formed from a group of 8 men and 7 women. And so we would want to figure out how many people or how many groups can we make basically of 6 people. So there are 15 people available. I'm going to choose 6 of them. That's 5,005. And now the reason I want that number is because I'm going to use that in this first problem. It says, what is the probability that the committee selected has exactly 4 women? So probability of 4 women. And so I want exactly 4 women. So that part goes up on the top. So there are 7 women available. I want 4 of them. But then I have to continually ask myself, is my committee full? And it's not. So that means I need to have 2 men. So this is the 4 women. This is the 2 men. When I go figure that number out on my calculator, I get 980. The bottom is just going to be this. 15 choosing 6 people. We get that 5,005 number. And when I divide these and then I round to the 10th of a percent, I'm going to get 19.6%. Okay. All right, part B, let's go look at that one. And again, you should have this already filled in. You should not just be copying what I put up here. All right, what is the probability that the committee selected is at least 4 women? So I could have 4 women, or I could have 5 women, or I could have 6 women. Well, the 4 women we already did. That's 19.6%. Okay. So I'm not going to redo that math down here because I already figured that out. Or remember means add. Now on this one, I'm going to need a little math problem. So there's 7 choosing 5 women, and then I need 1 guy, so 8 choose 1, and then over that 5,005 number. And so when I go 7 choose 5, 8 choose 1, I believe we should have gotten 168. When I divide by 5,005 and I round it to the 10th of a percent, I believe I get 3.4%. And then if we want 6 women, well, that's going to be easy because that means there's no guys on there. So just 7 choose 6, which I can do in my head. Remember, when these are 1 apart, it's just whatever the front number is. So 7 divided by 5,005, I get 0.1%. And so now I need to add those 3% together, and I believe I get 23.1%. So there's a 23.1% chance that we get a committee that has at least 4 women on it. Okay. All right. So lesson 2.2, hopefully we are able to find the probability of an event with combinations and the fundamental counting principle. Okay. So you need to do the lesson 2.2 homework in your packet. If you're in the distance learning group, do the 2.2 lesson on Schoology.